Hey guys, welcome to lesson 1B. We are doing today solving quadratics by completing the square. So how do we do that? So the warm up, if you remember how to solve by completing the square, go ahead, pause the video and do it. Otherwise, we can do it together. So let's get started. What happens is, first of all, you want to make sure your constant is moved over. So this is your constant. It's already on the other side of your equal sign. And your leading coefficient should be 1. Only then can you complete the square, which is 1. Right? So I'm going to rewrite this. X squared minus 5x. And I am going to give a space here. Equals, I go back to this, negative 6 plus, and I'm going to give a space again. If I gave space on one side, I'm going to give a space on the other side. Now, how do I find what number goes in there? Okay, so this is the most important part to remembering how to complete the square. Do you see this number, this b? You basically take your b, which is negative 5. I'm going to say b is equal to negative 5. You're always going to divide that by 2 and always going to square it. So what is that equal to? That is, if you square a negative number, it's going to be positive. So 5 squared is 25, 2 squared is 4. Leave it in fraction form. You don't have to give me decimals, please. So that's the number that will go here. So this is going to be 25 over 4. So I added 25 over 4 here. I'm going to add 25 over 4 on this side, right? Now, you want to factor this. This is going to be a perfect square. The left side, you're going to factor this. This is going to be a perfect square trinomial. So you need two numbers that add to negative 5 and multiply to 25 over 4. It's a little tricky, but you'll be like, oh my God, they're fractions. How am I supposed to do that? But let me teach you the trick. Do you see this negative 5 over 2 here? It's always going to be that number, your b divided by 2. So it's going to be x minus 5 over 2 square. If you multiply this out, if you write it out, you will end up with this. You can always check. It always works. So you don't have to worry whether it's a fraction, not a fraction, a large number, small number, whatever kind of number you get, you'll be good. So on the right side, let's simplify this. Negative 6 plus 25 over 4. So we are going to be taking, how do you add or subtract fractions? Your LCM is what? I'm going to put this over 1. Your LCM is 4. You're going to multiply this by 4. And you're going to multiply the numerator also by 4. So 4 times negative 6 is negative 24 plus 25, right? So what do I get here? I'm going to change colors. I get 1 over 4 on this side. I have x minus 5 over 2 squares, right? Now I want to solve for x. That's our whole goal. So what do? Take the square root. How do you undo a square? Take a square root. Whenever you take a square root, remember to put the plus and minus. The square and the square root cancel out. So I am left with x minus, let's zoom in, x minus 5 over 2 equals, remember this is same thing as square root of 1 over square root of 4 and plus and minus. So it's going to be 1 over 2, 1/2 plus and minus 1/2, right? This will become, I'm going to add 5/2 on both sides because I want to solve for x. So I get x equals, this cancels, x equals 5 over 2 plus and minus 1/2, which is same thing as writing x equals 5 minus 1 over 2 and 5 plus 1 over 2. So my two answers, I'm cramming up in here. So my two answers are x, let me switch colors so it's a little more clearer. 5 minus 1 is 4 over 2 is 2, and this would be 5 plus 1 over 2 is 6 over 2, which is 3. So you get the same answers. If you go back to your lesson 1A, we did the same question by factoring. We did it by quadratic formula, and now we did the same question by completing the square. And no matter which method you picked, you ended up with the same solution. So it doesn't really matter whatever you're comfortable with, unless the question was being very specific that you need to do it a certain way. So note, a quadratic equation can be factored to find all rational solutions. Completing the square will find all solutions, whether they're rational, irrational, or imaginary. So basically, completing the square works for everything. It's like really good to know. You can find all solutions and they're all simplified, so you don't have to simplify them, especially the radicands, right? So let's get started with example 1. So example 1, again, you're solving for x and you're given this equation. Again, with the completing the square, you want your x terms on one side. So I'm going to subtract 3x, so I get what? Subtract 3x on both sides. And I'm also going to move my constant over, add 2. So this is what? X squared minus 2x. This cancels, and I'm going to give a space also, plus, and this is negative 33, right? Actually, I just want to change that color because we're just giving the space in blue, right? Oops. Equals negative 33 and then plus the space. So now what numbers goes in there? It's first, before I even check, always make sure your leading coefficient is 1, which is 1 in this case, right? So now what number goes in here? It's gonna be your b. What's your b? Negative 2 divided by 2 square. What's negative 2 divided by 2? It's negative 1. Negative 1 square is just 1. So 1 will go in here and it's going to be the same number. On the left side, I know it's going to be the right side, it's going to be negative 32. I want to factor it. And what did I tell you in the last questions? Always this part. What's negative 2 divided by 2? It is negative 1. So it's going to be x minus 1 square. So x minus 1 square. And you can check, give me two numbers that add to negative 2 and multiply to 1. It is negative 1 and negative 1, right? Now what do? Take the square root because you want to undo the square. What do you get? X minus 1 equals, let's simplify that. 32 is a non-perfect square and I also see a negative, so I know some kind of I will be involved here. I'm going to do that on the side here. Negative 32. So I know it's going to be negative 1 times, what's the largest perfect square that goes into 32? 16 times 2. Either you can have separate radicals or put them all in same radical. Square root of negative 1 is I, square root of 16 is 4, and 2 is not a perfect square, so it stays under the radical. So I'm going to simplify this to, and remember your plus and minus. Plus and minus 4i rad 2. And my final step is add 1. These are not like terms, so you can't add them. So it will be x equals 1 plus and minus 4i rad 2, right? And that's how you solved it for x. So let's try example 2 again. Again, what are we doing? Make sure your constant is moved over. One of the constant terms, negative 9, is there, but I need to get rid of this. So add 38 on both sides. What do I get? X squared minus 9x. This cancels. Let's do this. And I'm going to give a space. And this would be what? 29, right? And I'm going to give a space. I wanted to do the space in blue. This is what? 29. And then plus a space, right? What I do on one side of the equal sign, I do the same thing on the other side. So now, what number goes in here? So I'm going to take my b, which is negative 9, divide by 2, and then square it. I told you, it's always going to be the same process. Divide by 2, square it. That's what's completing the square. So what do I get? Negative 9 square is 81, 2 square is 4. So I want you to leave it as a fraction. I don't want you to simplify it. So this is going to be 81 over 4 and 81 over 4. Oh. So now let's factor this side. What did I tell you? It's always gonna be this number. Give me two numbers that multiply to 81 over 4 and add to negative 9. It's gonna be negative 9 halves. And two of the same quantity squared, right? And what do I get? You can actually put it in the calculator or find the LCM is 4 and multiply by 4 in the denominator by 4 in the numerator, which would be 117 plus 81, which is 197 over 4. Now it's simplifying it. It's pretty straightforward from here on. Take the square root. When you take the square root, make sure you put the plus and minus. So the square and the square root cancel out. You are left with x minus 9 halves equals, remember, if you have a square root in the numerator, I'm just going to write this. 197 over 4 is same thing as this. 197 is a non-perfect square, but 4 is a perfect square. So it's going to be square root of 197 over 2. Add 9 halves, add 9 halves. This cancel, I get x equals 9 halves plus and minus 197 over 2. And you can't really simplify it further, so this is your final answer. Okay, so finish up the remaining packet. If you have any questions, please reach out to your teacher.